Hi everybody, my name is Bhavishya, and in this lecture, as we are done with the OSPF, we will learn about firewall. But before jumping into firewall, there are some prerequisites that has to be done in order to learn about firewall. So, the very first thing, the basic one, that is, let's suppose we want to ping from our, not ping, let's suppose we want to send packet from our PC1 to PC3. So, for that, what will happen? In order to send from PC1 to PC3, the very first thing that is required, it's a very basic one, that is our source IP. The source IP will be 192.168.10.1, right? The destination IP will be, as we are sending it to PC3, the destination IP will be 192.168.20.2, right? By the way, this is 20.1. Okay. And in return, in the return way, source IP will be 192.168.20.2 and the destination IP will be 192.168.10.1. Right. Now when it comes to ICMP, then in the IP header, then in the IP packet, in the IP header, there is this IP protocol. We'll set the value to 1 as 1 indicates our ICMP. Right. After that, in the ICMP packet, there is this ICMP type. There is this ICMP type. So there are two types. The very first is our ICMP request, and the value of the ICMP type of this ICMP request is R8, or you can say ICMP request or echo request. Let's name it as echo request. And the second one is our echo response, and the value for this is 0. Right. Now, as we know the basic, let's see the workflow of our when PC1 will ping to PC3. So what is going to happen is, as you want to ping from PC1 to PC3, the very first thing is we'll create the ICMP packet. In the ICMP type, we will input the value as echo request, right? 8 value. After that, that will encapsulate in our IP packet. In the IP packet, we have IP header. In that IP header, there is this IP protocol. There we will select the value as 1, which indicates for ICMP. After that, we will encapsulate that IP packet to our Ethernet. Then Ethernet will reach to router. Something will happen. Here also flooding forwarding will happen. And then finally, when it will reach our PC3, the very first thing it will go and check for is our destination IP. If the destination IP of our PC1 matches from this what it has intended to send, then it will accept the packet. Now, it has accepted the packet, let's suppose, because the destination MAC was similar to what PC3's MAC is. Now, it will see in the Ethernet type is 0800, which is our IP. Then in the IP packet, it will see the IP protocol is 1, that is ICMP. So it will decapsulate the ICMP packet. There it will see, okay, the type is my 8, which is my echo request. So now PC3 will make a ICMP response for it, right? So it will input the type value, the ICMP type value to echo response. We'll select the value to 0. After that, it will encapsulate it to IP. In the IP header into IP protocol, we'll select the value to be 1, right? Then it will encapsulate it to Ethernet. Then it reaches our layer 2 switch. It will do its forwarding flooding, then router, it will do its own thing. And then let's suppose it has reached to our PC1. We'll check the destination MAC. If the destination MAC is same, then it will see, okay, in the Ethernet type is 0800, which is IP, and then in IP, the IP protocol is ICMP. Okay, in the ICMP protocol, the ICMP type is 0. Okay, it's a IP response. Then the ICMP protocol will work and the ping will end here. So this was a workflow of our when how PC1 pings our PC3, right? Now let's suppose our PC1 wants to send something to our server. But here, instead of ping, we are using UDP connection, or let's suppose TCP connection. But before that, let us revise our UDP and TCP. First, let's suppose TCP. So as you know, TCP, it's a connection oriented where handshake happens before transfer due to the reliability. So as you know that three-way handshake happen are SYN, ACK and ACK. And as you know in the data transfer, we segment the data and then we use the sequence number and then it reaches the receiver, then it will send the acknowledgement, and if the acknowledgement is not there, the sender will retransmit it, and the retransmission will happen according to the duplicate acknowledgements or timeout, right? And TCP also has this congestion control that it the sender can adjust the speed of sending with the help of algorithms applied on it with the on the basis of our acknowledgements and packet loss signals, right? And also at the end, when the transfer is completed, it has the ability to tear down the connection with four-way close or fin ACK pairs, right? So this was it for TCP, and we use it when we want reliability, right? And it's a slow one as compared to UDP. And if we talk about our UDP, so it's a connection less, right? It is an independent datagram. It sends directly a sender to a recipient, right? It has no reliability, no acknowledgement, no transmission, no auto guarantee. The only thing it has in its header is our source and destination, checksum and length, right? So this was it for our UDP. Now let's suppose our PCV, our PC1 wants to send in data to our our server with the help of UDP connection. For that, what will happen? Let me edit this. Now in this connection, when PC1 wants to communicate to a server with the help of UDP connection, the source IP will be 192.168.10.1. The destination IP will be 192.168.20.1. The source port will be random, but the destination port will be our, as this is UDP, right? 17, right? This is what we use as a port number. Now let's suppose PC1 wants to communicate to server with the help of our TCP connection, right? TCP. In that, the source IP same 192.168.10.1, the destination IP same 192.168.20.1. The source port will be still random and the destination port will be changed to from 17 to 6. Right, this is what we use for a TCP connection. Now let's suppose PC1 wants to communicate to our server with the help of SSH, right? Instead of TCP now, SSH. Right, for SSH, the destination port will be changed to 22, right? And also in the server, when you're communicating, the SSH package should be installed. The package of the SSH should be installed. here in the server. Right. When we talk about, instead of SSH, now we want to communicate to Telnet. For Telnet, the destination port will be 23. Right. And also that server, inside the server, the Telnet package should be installed. Right. And finally, let's suppose this is our web server. Let's suppose Apache server, and we are hosting a website. So for hosting a website, let me write it down somewhere. Now to host a website, for website host, the port is of two types. When the network is secure or the website is secured, we use port number 80 for unsecured. When it is secured, right? So in the connection, when it's secure, we use 443. Secured or encrypted, right? So this is what we use. So in place of our destination port, we will use these two values for specific hosting. Now, these were the prerequisite to understand our firewall. In the next lecture, we'll see how firewall controls the traffic and block in particular type of communication to happen. And also we'll see how rules are made for our firewall to happen. We'll see some examples as well. So this was it for this lecture. I hope you enjoyed. See you in the next one.